secondary schools. Contents: concepts of position, motion, and time. Calculation in physics for senior secondary schools. Contents: concepts of position, motion, and time. 1.1 will be dealing with position, distance, and displacement. In 1.2, we'll be dealing with motion. Under it, we look into friction and circular motion. In 1.3, we deal with speed and velocity. But at chapter 1.4, we deal with rectilinear acceleration. Then 1.5, we deal with scalar and vector quantities. In 1.6, we deal with projectiles. At 1.7, we deal with equilibrium of forces. Then in 1.8, we deal with simple harmonic motion. Then in 1.9, we deal with density and relative densities. Then we now do the exercise. Concepts of position, motion, and time. Then we are looking at chapter 1.1, the position, the distance, and the displacement. Position. Position is a location of a point using rectangular coordinates, x and y axis. When writing the coordinate of point, x is written first, then followed by y. Example 1. The point A in bracket x2 minus 3 closing bracket has the value of x as 2 and that of y as minus 3. Represent these points on the Cartesian coordinate. Now, solution. The horizontal components in a Cartesian coordinate represents x. So, tracing the 2 on that coordinate, it should be at the right hand side. Then, the vertical axis of the Cartesian coordinate is represented by y-axis. Then tracing the minus 3 on the coordinate is still on the downside of the Cartesian coordinate. Then when you join the two, tracing the 2 and that of minus 3, we will now reach at a point called A, which is now given A in bracket 2 minus 3. Distance and displacement. Distance is the product of average speed and time. Distance is equals to average speed times time. Displacement. Displacement is the distance traveled in a constant direction. Therefore, displacement is equals to average speed times time. Example 2. Figure 1.2 example show that a line having point ABC is 3 km. A body moving with a constant velocity along a straight line ABC takes 45 minutes to go from A to B and 10 minutes from B to C. If AC is 3 km, find AB. Solution. Making average velocity the subject of formula, we have that displacement over time as our total average velocity. Then their displacement is 3 km from the point A, B, C. Then we are now looking for the total time, which is the time it takes 45 minutes to go from A to B and 10 minutes to go from B to C. The total time, which we now have as 55, will be our time minute. Then the total average velocity of the movement is 3 over 55 km per minute. But displacement is equals to average speed v times time t. Displacement AB is equals to 3 over 55 times 45, which will give us 2.45 kilometer. Example 3. A man walked 1 kilometer due east and then 1 kilometer due north. Looking at this Cartesian coordinates of 3 cardinal points of figure 1.3 example, the man walked 1 kilometer due east and then 1 kilometer due north. Now we are asked to calculate, we will now find the resultant of the displacement. Solution. According to Pythagoras theorem, the square root of the hypotenuse is equal to the sum of the square root of the other two sides. Since the man walked 1 kilometer due east and then 1 kilometer due north, the resultant will be r squared equals to 1 squared plus 1 squared, which is equals to 2. Therefore, r is equals to square root of 2. Tan theta is equals to 1 over 1, which is equals to 1. Therefore, tan inverse of 1 is 45. Therefore, the displacement r is equals to square root of 2 kilometer northeast. Example 4. An aircraft traveled from Calabar to Kano as follows. It flew first to Ilorin, covering a distance of 300 km, 30 degrees west of north, and then flew 400 km, 60 degrees east of north to Kano. What is the resultant displacement? Solution. Figure 1.4 example shows the diagrammatic representation of the movement of the aircraft. The first coordinate, Cartesian coordinates, represent the movement of the aircraft from Calabar to Ilorin at covering a distance of 300 km, 30 degrees west of north. Then the aircraft have to take another route from that Ilorin to Kano in another Cartesian coordinate, which cover a distance of 400 km, 60 degrees east of north to take to Kano. What we are now looking for is the displacement, which is the resultant displacement from Kano to Calabar, which is now represented as r. Now looking for the angle inside the triangle of the Cartesian coordinates of the aircraft going from Ilorin to Kano, we have, that alternate angles are equal. So the downside, or the angle that the distance joined from the Calabar to Ilorin is 30 degrees. Then the remaining inside will be 60, since it is inside a right angle triangle of a Cartesian coordinate. Then the plane now flew at 60 degrees from that Ilorin to Kano, but since it is in a 90 degrees then the remaining angle inside that 90 degree is minus from 60, which is giving us 30 degrees. So inside that triangle, we are now having 30 and 60 degrees. Adding the two will now give us a 90 degrees right angle triangle. solution.